Okay, Nick, this is Daryl. How are you today?
Yeah, I'm alright, Nick. Dara. Pleased to meet you.
Okay, nice to meet you as well. So as Beta said, I'll just give you an introduction to the software. So currently I'm in the seepage module, as you can see to the top of the screen. Um, I'm sure Beta already told you that the software itself is comprised of 7 different modules, each of which has its own particular purpose. So currently the seepage module is
Yeah, yeah.
it's typically used for seepage analysis. So for example, if you have a dam or embankment or any type of flooding scenario and you want to see the effects of, I guess, saturation or poor water pressure on your project site, you would use a seepage module.
Mhm.
So what I'll do is I'll just go through the basic process that you would go through to create a seepage model of a dam project. So the first thing that you'd want to do is you'd want to import your project geometry. Now with SoilWorks, you can either draw it yourself. If I open up this tab here, and I want to make sure that it's sort of coming through on your screen. Do you see to the top left, I opened the geometry tab, and do you see all the icons and the commands?
I could see the geometry tab, though. All the icons here, the lines, the arcs, the circles,
Okay,
rectangles, and those things.
perfect. So are those commands familiar to you?
Yeah, yeah, they're familiar, though.
Okay, good. Yeah, so I assume you're very proficient with AutoCAD. So the great thing about the program is that any sort of AutoCAD user can just use their skills, or the skills just translate directly into the program. So what you would be able to do is you'd be able to create all of your own drawings just on the program itself, just using these commands. Now let's say, for example, oh, and actually let me give me a second here. I'm going to try to adjust the screen resolution before we move forward. This will just take a second. So now, as I discussed, you can use all these geometry-based commands to create your project geometry. Another great feature of the software is you can actually import files or AutoCAD files directly into the program. So instead of having to redraw a drawing that you've already done, you can just import it directly just by using this option here. So if you go to the top left here and click on the SoilWorks icon, and I just clicked on it, do you see the drop-down menu that came up?
Okay, I see the click, though. When you see the drop-down menu, no, okay, now, yeah, yeah.
You see it now? Okay. So sorry,
No, I
it's
see it now.
yeah. There's a bit of lag time. I think there's maybe 10 seconds of lag time between my computer and your computer. So I'll just try to do this slowly. So as you can see, if you just go to the import option, and let me just wait for you to catch up here, and then you can just select your DWG drawing, or your DXF or DGN drawing format. So what happens is you just select it, and what it will do is the program will allow you to go through your computer and select the drawing that you would like to import. So for this project, I already have a specific drawing in mind. So it's this one, stability check for a river levee, and it's in a DWG format. So what I'll do is I'll just double click on it, and then within just a second, it's already imported into my my work window here. So do you see, like on my main screen here, do you see the drawing of the dam?
Oh, no, not yet. I still have the CAD file, DWG drawing.
Okay. Alright, so sorry, I think there might be an issue with our internet connection. That's why it's running slow today. We're having some maintenance done, and I think that's maybe why our internet's not as fast as it usually is.
Okay. Okay, right now I'm at the dam stability check for river levee.
Okay. And then, yeah, then I double clicked on it, and okay, do you see it now?
Yeah, I see it. I'm
Okay.
seeing it.
Perfect. So yeah, that's another great feature of the program is, once again, if you have any sort of drawing done in AutoCAD, you can just automatically import it into the program. So that could, save you a lot of time and hassle in the long run. And also, if you have maybe like a drafter who
Oh, let me
specializes
ask,
in... Oh, you do it all yourself? Okay, perfect. So that, should streamline everything
yeah,
for you.
go ahead. If what you say, if there's a drafter one, specializing in one?
Oh yeah, well if you have a drafter that does all your AutoCAD drawings, what you can do is you can just get all of your files from him, and then you can just import them directly into the program. So it makes it faster for the both of you.
Okay, question in terms of the data, in terms of the elevations and those things, all of that from the drawing will be transferred into the program.
Yeah, but an important thing to remember, though, is that to keep your units consistent, for example, if you did the AutoCAD drawing in meters or in feet or whatever, make sure that when you import the drawing into the program, that the units are the same. So, for example, if you look to the bottom right, those are my units, and my units for length are in meters. So, for example, if I were to do the drawing in
Right, right.
feet or just kilometers or whatever, it's really important just to make sure to change it. In order to change your units, you just click on the drop-down menu and you can just select them accordingly. And also, like if you're in the middle of your project and you want to change the units, you can just go to that drop-down menu, and the program will do all the conversions for you. So that's another feature of the program to help you out.
Okay, very well.
Okay, so now that I have my drawing imported, the next thing that I would need to do would be to generate my material properties. So for example, since I'm doing a seepage project, I would need my permeability coefficients in the horizontal and vertical direction. So if you go up to Model, and then go to Ground Material Property, and I'm just going to wait because I can see what's sort of going on your screen, and it's taking a while to catch up. So I'll just wait until my computer catches up to, or your computer catches up. So you
In
do
terms
still.
of dam, you have, Bevan?
What's that?
No, I'm saying in terms of the dam you have constructed there, your levee basically, you have at the two here, you have like, is that your key construction or that's the key, the form of the key that you're constructed?
Oh, well, I mean, as far as the dam itself, this is just a side view of the dam. And, the embankment, would consist of those two sort of top layers. So you can see it sort of looks like a hill. And then that square to the right, it's like some riprap. It'll look a lot clearer once I fill it out. Okay, so do you see the ground material properties?
Right, right.
Okay, so as you can see, just in the interest of time, I've already defined all of my ground material properties. And since this is a seepage project, the only material properties that you really need to concern yourself with are the permeability coefficients and the porosity, as you can see. And then also, if you click on, let me click on, for example, weathered soil, if you have something more detailed, you can open up the unsaturated property functions. So, for example, if you have like your own functions that you want to import, and I'm sorry, can you see the functions on your screen right now?
Yeah, I'm looking at, still in the dialog box where you see define ground material properties.
Okay.
Horizontal permeability, vertical.
Okay. And then I'm not sure. Do you do many dam or embankment type projects where like a seepage would be something that you would need to analyze?
Yeah, well, yeah, like levees and those stuffs.
Okay,
A
perfect.
dam every how often you would do a dam, but like, more like levees.
Okay, perfect. And when you're doing those types of projects, do you do the seepage analysis by hand, or do you have some kind of program to do it for you?
Yeah, most times you would have to try and model the seepage. Yeah.
Okay, excellent. And then how do you feel about the performance of like your current programs? I mean, do you feel like they're effective for you as far as doing the seepage analysis?
Yeah, I think so. I think they're effective.
Okay, excellent. So, SoilWorks is very sort of adept at seepage analysis as well, but another sort of great advantage of it that sets it apart from other programs is that in addition to doing the seepage analysis, you can also run a coupled analysis. So, for example, with this particular project, what I'll do is I'll show you how you can import your, pore water pressure loads into your slope stability analysis to, make things a lot faster and a lot easier for you. But yeah, before I continue, I just want to make sure, can you see the graphs now?
Yeah, I can see the graphs.
Oh, you can see them? Okay. All right, perfect.
Yeah, I can see the graphs.
Okay. So, you have two types of graphs that you need to concern yourselves with as far as, permeability functions. First is your pressure load versus your K ratio to the top here. And once again, this graph is user-defined, which is, typically the best scenario that you have something detailed like this. But for example, if you have maybe just a type of function that you want to use, you can open the drop-down menu, and you can create a function that can sort of give you an estimate of what your behavior would be. For example, your Gardner coefficient, the frontal function, the Van Genuchten, those are all available to you on the program. And then same with water content. You can create your own user-defined graph, but you can also use sort of an equation to sort of get an estimate of what your graph would be for your unsaturated behavior. Okay. So as you can see, I've created material properties for all of them. And what I'll do is I'll assign these material properties to my project. So what I'll do is I'll X out of this for now. And then next, I'll create some surfaces. So I X'd out of the ground material property menu. Is it still showing up on your screen?
And I'm still on the wetted soil thing, dialog box.
Okay, so it'll just take a couple of seconds to sort of catch up on your side of the computer, or on your side. So before you assign your material properties to your drawing, you need to first create what's called surfaces. So as you can see, all of these enclosed domains will be assigned material properties, but before you can do so, you need to tell the program that those domains have these surfaces that can be assigned material properties. So in order to do that, just go to Model,
Okay.
and then, or excuse me, go to Geometry, and then click on the tab that says Smart Surface. And then within a couple of seconds, all of your enclosed surfaces will be colored, which means now the program recognizes that these surfaces can have material properties assigned to them, structural or typically ground material properties assigned to them. So yeah, I just did that on my computer. I clicked on Geometry and then I select Smart Surface, and now all my enclosed areas are colored in, and it should show up on your computer now. Okay. Perfect.
Yeah, it's there. It's there.
Excellent. So now what I'll do is I'll just select these surfaces and I'll assign them ground material properties. So in order to do that, just window each ground material property, then go to the work window on the left, and then as you can see under ground material property, once I open that tab, I know it's still not showing on your computer, but once I open it, there'll be a list of all the ground material properties that I created previously. And what I'll do is I'll just drag and drop. So I'll select the material property that I want assigned to the layer. So as you can see, the bottom layer is in blue. And then I'll just select weathered rock, and I'll pull it into the work window. And then the material will be assigned to it. And I'll do that for all of my layers here. So I'll do the same for weathered soil, for the alluvial layer, and then for the existing layer, then the embankment that's to be constructed, and then for the riprap as well. Okay, so what I did was I just, using the work window to the left, I was able to assign all my material properties to my model. Okay, so the second layer, I highlighted the orange layer. I highlighted it, and it should be blue now. Did you see that yet?
No, not yet. Huh?
Okay.
What do you do? What do you do in terms of like changing it and inputting the properties? You right click on it, or you just go into the property?
You just window the surface. So what you do is you create a window over the surface, and then once you do that, the entire surface will be selected, or it'll be highlighted in blue. And then once you have your surface selected, you just select your ground material property from the left or from the work window, and then you just click on it and you just drag it over to the work window or to your model.
Also, those ground properties you have, they are like preformed. They have been preformed, pre-selected with the permeability data and all of that.
Yeah, typically engineers, they just have permeability data from, for example, from lab tests, or they have certain records or just ground data that's available to them.
Okay.
Yeah. So that's typically where you get the data should be available. Whenever you're working at a project site, they'll have certain things ready for you, just so that you can run your analysis.
Okay.
So I guess I just want to make sure everything ran through, because there might be some lag time on my screen as well, as far as what happened and what transpired on your screen. So if you look to the left, all the ground material properties, are they in blue lettering or in black lettering?
Black lettering.
Black lettering. Okay, so I mean, did you see how I was able to drag and drop all the material properties onto the model?
Yeah, I think I saw you just drag them and you put the box over there.
All right, perfect.
Yeah.
So now the next step of my analysis or my modeling would be to assign my water level. So for this embankment, the water level will be on the left side of the embankment, whereas the right side will be dry. And because of that, because there's high water pressure on the left side, water is going to seep from the left side over to the right side. So what I'll do first is I'll just model my water level to the right side, or excuse me, the left side of my embankment. So in order to do that, I go to Boundaries, that top tab, and then select Nodal Head.
Okay.
I just opened the Boundaries tab. Do you see it open?
No, not yet.
Okay, so I'll wait until it catches up.
My question is that in terms you have your dam here preformed and all of that, yeah? Hello?
Yeah, I mean, you mean like as far as the geometry?
Oh, go ahead, look the boundaries.
Okay, it's open. All right, so next you just select that icon all the way to the left that says nodal head. So I'll click on that now. And it might take a few seconds to catch up on your computer. But what I'll do is I'll just assign my the static water level. And you do that just by selecting the curves, so all the curves on the left side of the dam. And then the nodal head value, or the height of the water with reference to the origin, would be 18.42 meters. So I type that in.
Okay.
And then just click OK. So now all of the sort of spots here to the left, or all my curves here to the left, have 18.42 assigned to them, because that's where my static water level is. So do you see the boundary assigned to the left side?
Yeah, I was asking a question in terms of the actual construction, say, of the levee. You know that when you're constructing those levees, you would probably construct them in lifts of probably about, say, every so many. Okay, I see the nodal boundaries though.
Okay. So it says 18.42, so that just means the water level is 18.42 meters, and that's with respect to the origin. So the bottom left corner here, or where my axis is, that's 0, 0. So 18.42 meters is just about, I'd say, near the top of the levee, but not completely, to the critical point.
The bottom shows 0, 0, or I see the bottom showing 18.42.
Oh, I'm sorry. The bottom, I mean the origin. So you see the axis, right, to the bottom left, that sort of orange or that yellow triangle, or excuse me, square. That's the origin. That's 0, 0. And then all of these nodes here, they say 18.42. That's referencing the height of the water.
Okay, okay.
Yeah. So actually, before I go on with this, let me just do the meshing real quick. So as I'm sure you know, with finite element analysis, you have to create your mesh sets for your models. So in order to do that, just go to Model and then just select Smart Mesh. So what I'll do is I'll just wait until that shows up in your computer. So I clicked on the Model tab, which is right next to Geometry. So do the meshing options show up on your screen yet?
No, not yet. Huh?
Okay, so I'll just wait a couple of seconds here.
You go to Geometry or Model? Which one do you?
Oh, you select Model. And I forgot to ask, have you had a chance to try out the software for yourself yet?
Which one?
This software, SoilWorks.
No. It does not operate on a Macintosh platform. No.
Oh, you
Macintosh.
use Apple computers.
Yeah.
Oh, okay. Interesting. So you don't have any sort of Microsoft computers then?
Yes, I do, but I'm a bit more familiar with my Macintosh.
Okay.
So if I would have to go into a Windows system so that I could probably run the program.
Oh yeah, absolutely. Okay. So you should see the meshing options now. So here under the mesh sort of tab here, you can see all the different options that you have for creating your meshing. So the ones to the right, for example, map mesh, grid mesh, FC, those are just sort of manual options that you have for creating your mesh. But if you want to create a mesh very quickly and very efficiently, you just select Smart Mesh, and you just select your sort of parameters. Okay, so I just created my meshing. So I know it's not showing up in your screen yet, so I'll just give your computer a few seconds to sort of catch up before I move forward.
Mm-hmm. Okay, take care. I will immediately check my email again.
Okay. Yeah. I'm sorry. Are you still there?
Oh, okay, yeah, I'm still there, you know. I could see the mesh though.
Okay, yeah, so as you can see, doing the meshing is very simple. It's just a matter of selecting, your options as far as how fine you want the mesh. And as you can see, the program automatically sort of recognizes where the mesh needs to be finer. So the closer it gets to sort of
Right, right.
where the materials change or, closer towards the surface, the material becomes more fine, or the meshing, excuse me, becomes more fine, so that your
It
analysis,
becomes more fast.
yeah, so it can be more detailed around these areas. Anyway, so now that I have my meshing done, I have my left side boundary. What I need to do is create a boundary to the right side to tell the program that there's seepage going there. So for example, the right side of the embankment, it's dry, but because I want to analyze sort of pore water pressure as well as volumetric flow to this side, I'll need to assign this a boundary called a review boundary. So if I just go to boundaries and then select review boundary, what I'll do is I'll just give your computer just a few seconds to catch up.
Yeah, I could see the mesh for the backside of the levee, yeah.
Okay. And I guess with the programs that you use, I mean, do you do much meshing or much finite element?
Yeah, yeah. I do meshing though.
Okay, excellent. And I'm sure you're familiar with those auto meshing sort of features. So once again, this
Well,
is what's that?
yeah, the meshes will be generated automatically.
Yeah, it's very simple to do, especially with this program. So now under boundaries analysis, click review boundary. So the tab right next to surface flux and water level. Just click on that, and then select your curves. So what I'll do is I'll just select all the curves of the right side of the embankment. And I'll name it review. So just keep in mind that whenever you have an area of low water pressure and you're expecting sort of flow to go through it, just to assign it a review boundary. So that way the program recognizes that these curves need to be analyzed for seepage. So just click OK. And now I have my review boundary, and once again I'll just give your computer a few seconds to sort of catch up. But once it shows up, you'll see sort of a series of red squares on the right side of the embankment, just to let you know that the that side has been assigned the review boundary.
I have a question in terms of inputting the nodal boundaries, where you have the 18.42 water head on the left side of the embankment. You said at the very bottom of the surface you have there is 0, and considering, let us say, at the riverbed, the difference, well, why is it that you have 18 all along the slopes of the 18.42 all along the slopes of the levee, and it doesn't change like let us say from say 0 or from 18 going up?
Okay, so the 0 point is from the origin, so not from the bottom of the So the origin is to the bottom left corner where the x and the z-axis intersect. So that's 0, 0. Yeah. So then what you're telling the program is that for all of the curves to the left, the water level is 18.42 meters. So 18.42 meters is near the top, but not all the way to the top. So it's right around
the top of the embankment.
Yeah, it's near the top of the embankment. So all along that surface, the program recognizes that the water level is 18.42.
It's up. Okay, okay, all right. So it's 18.2 from there. Okay, no problem.
Yeah, no problem. Excellent. So yeah, I mean, it should show up on your computer now. Does the review boundary show up?
Yeah, I see some review boundaries on the left side too, though.
Oh, on the right side, you mean? Like just the squares, the red squares to the right?
Yeah, I see the squares on the left, on the right side, though.
Perfect. So
and
now
I see a surface coming.
Okay, excellent. So yeah, now that we have that done, we can just create our analysis case. So go to Boundaries, Analysis, and then just select Analysis Case. So I know it's not showing up on your screen quite yet, but I'll just get everything ready so that we can sort of move along. And okay, so you should see it now. I'm creating my analysis case. So all the everything to the left, that's just the data that I created, all of my mesh sets, the boundaries that I did to indicate my water level and my review boundary. I'm just selecting that and putting it over to the right for the analysis or for the data that will be used. Yeah, so that's my analysis case. And another important thing to keep in mind is that with the software, you can create as many analysis cases as you'd like in a single file. So for example, if I had different combinations of, for example, mesh sets or boundaries, or if I wanted to create maybe like a variable or a transient static water level on the left side, I would be able to do that. And then later on, I guess maybe when we're doing maybe a more advanced training, I can show you how that's done. But that's another useful feature in that you can create multiple design cases or analysis cases and compare the results against each other. So that way when you're doing your design, you can see several different sort of designs that you make, and you can pick the one that works best for you. So now I have my analysis case created, and I can just run my analysis, so I'll do that. So I'll just go to Analysis, and then I'll click on Perform Analysis. So right now the analysis is being run on my computer, and it should show up on your screen within just a couple of seconds.
Okay.
So yeah, while we're waiting for sort of the lag time to catch up, do you see like this program being possible to use for you for any of like your seepage projects or your dam type projects?
Yeah, I could think of one, upcoming.
Okay, excellent.
Some levees that have to be constructed along a river.
Mm-hmm.
So that is something that can be used.
Okay, excellent. So with this like seepage project, I'm assuming you're obviously doing the seepage analysis, but are you doing the slope stability analysis with it as well?
Yeah, well, most probably a slope stability analysis would have to be conducted.
Okay, and do you have like another, I guess, a separate program that does all your slope stability work?
No. Use the same program.
Okay. So are you able to, sort of import your seepage results into the slope stability analysis easily?
Yeah, not all that difficult.
Okay. So yeah, a really sort of strong advantage of the SoilWorks in particular is that, what I'll do is I'll show you, after I show you the results for the seepage analysis, what I'll do is I'll take the pore water pressure loads and I'll import them into my slope stability analysis, and I'll sort of show you how the program, it sort of cuts out a lot of the harder work and makes things really easy for you as far as doing a coupled analysis with seepage results.
Okay. So I'll be CP. Oh, wow.
Okay, so do you see it?
Mm-hmm.
Okay, so now we're in the results menu, and currently, if you look to the left here, all of the results are sort of listed for you. So I only have one analysis case, so these are just the results that I have. But here I have my nodal seepage results. I have my total head. So as you can see, because there's water pressure is high on the left side, and actually, let me change the settings of the window so you can get a better view of the legend. Okay. So yeah, since the water pressure is high on the left side, all of that's in red, and then it goes sort of off into blue because there's no water pressure on the right side. So typically with FEA software, all the critical or all the higher results are in red, and the lower ones are in blue. And then just using the contour graph, you can sort of just judge at a glance what your values are for your various, for your head, your pore water pressure head, etc. So what I did was I changed the background of the screen from black to white, so it should change on your end as well within a couple of seconds. Because if you look to the right there, sort of that bar, that rainbow bar, you can use that legend to sort of get, to sort of estimate, what sort of precisely your results are as far as your contour graphs. So once the screen changes to white, you'll be able to see the numbers a lot clearer. Okay, so has your background changed to white yet?
No, not yet. Huh?
Okay. Okay, so I think it's, yeah, because I'm monitoring sort of your view screen here. It looks like it should be changing very soon.
Okay, yeah, it's changed now.
There you go. So if you look to the right, you can see all of your sort of results, your nodal head, your total head, excuse me, your nodal seepage, your total head, and it gives you the units, which are in meters, and then, once again, you can use that sort of legend here to get a better idea of what your values are exactly. And then what I'll do is I'll just
Are these
quickly go through.
percentages?
What's that?
Are these percentages of what? The head in meters? Total
Oh,
head?
no. Oh, the percentages are just how much is each color occupies. So 18% of your model is
Oh,
18%. Excuse me, 18% of your model is red. 5.6% of your model is blue, so on and so forth. Okay. And then I have my pore water pressure head, my pore pressure, and then my phreatic line. So my water level, the program extrapolates that as well, and then flow quantity, how much is flowing through a certain portion. So those are my nodal seepage results, and then also because it's an FEA program, I can also get my ground element seepage results. So my horizontal velocity, my hydraulic gradient, my coefficient of stability, so on and so forth. And I know it's still got a ways to sort of catch up on your side, but once it sort of shows the windows opening, you'll see like the level of detail for that you'll be able to get with the program. So what I'll do is I'll just wait for the program or for the lag times to sort of catch up so you can go through the different results, and then I'll just do a slope stability analysis, and then I think we should just maybe wrap up for today after that because the lag time is really sort of slowing down how much we can go over. So what we'll do is, because there's still sort of people working on fixing up the connection over internet, so hopefully maybe during a following session we can have a better connection, and then we can maybe work a little faster. Okay, so yeah, it should be changing on your screen now, so you should be going through all the different results.
no, yeah, I'm at nodal seepage right now.
Okay, so all of those results are available to you as far as the analysis. So anything that you might need for your seepage analysis, you can just find it just through filtering through that menu there.
Strain seepage, yeah.
Okay, so now that I have done my seepage analysis, let's say I want to do a slope stability analysis for the right side of the dam or the embankment, and I want to see how pore water pressure loads affect it, how it affects the factor of safety. So what I can do is I can just switch from the seepage module just directly to the slope module. And I would do that by going to the top left corner and clicking on the slope module icon. So what I'll do is, I know you can't see it right now on your screen, but I'll do it now. And I'll just click yes. And within a couple of seconds, you'll see it. And it's just really easy. It's just a matter of saving your project and then going off into the next module. And what's really great about that option is that all of your project geometry gets carried over, so you don't have to redraw your model in another program. Everything is sort of carried over, so that saves you a lot of time. And I know your computer's kind of behind, so what I'll do is I'll take care of a couple of steps right now, and then once I see it sort of showing up on your screen, I'll go over what I'm doing. Okay, so I'm monitoring your screen right now. Currently, I mean, it's telling me that your screen still has that blue sort of model. Is that still on your screen?
No, no. I have an orange and red model.
Orange and red model. Oh, okay, so there must be lag time on my view screen then. Okay, so did you see that me create new material properties?
Beg your pardon? Yeah, I see the box, define ground material properties.
Define ground material properties. Okay. And have you seen me sort of assign them to the model yet?
Beg your pardon?
I'm sorry. Have you seen me? Did it show up on your screen? Did it show me assigning the material properties to the model yet?
No, no. I just see the model. In addition to the model type, let us say you have a more column. You could have other different types of models, like let us see.
Oh yeah, let me open it for you. So in addition to more Coulomb, under model type, that drop-down menu, if you click on the arrow, you get more Coulomb LEM and the elastic ground constitutive model. But that's specifically for slope stability. So for example, if you're doing like an excavation or retaining wall type project, you'd also have the hyperbolic constitutive model, Drucker-Prager, Tresca, Howick-Brown for your rock materials. So all those constitutive models are available to you. It just depends on, because of the model that you're using, or excuse me, the module that you're using, each one has sort of different constitutive models to choose from. But since this is a slope stability module, typically, more Coulomb LEMs is typically the most common one used, so it's included there.
Very true.
Okay.
Yeah, I saw it, so I was just asking, I know to myself, you could probably use a hyperbolic model or something on that, so and there are many different options.
Okay, yeah, what I'll do is after I run the slope stability analysis, I'll just sort of show you in the ground module all the different constitutive models that are available to you, because it's the ground module that has the most constitutive models, because typically it's used for excavations, retaining walls, tunnels, things like that. So what I'll do is let me just do a quick check here to see how synced up we are. I just clicked on Limit Equilibrium Method, that tab, and I have my cursor over the arc failure surface icon. Can you see that?
Your cursor, where is your cursor?
It's over an icon that says arc failure surface, and it's sort of like a picture of a slip surface or a circular slip surface for the slope.
No, I'm not doing it.
Okay. So yeah, it's probably going to take a few seconds to catch up. So yeah, just in the interest of time, what I'll do is I'll just create my arc failure surface, and then once I see it showing up on your screen, I'll just sort of show you what I did.
Okay.
Okay, so what I did was, I drew my arc tangent for my limit equilibrium analysis. I don't think it's showing up on your computer quite yet, but just give it a couple of seconds, and you'll see that if I just go to Limit Equilibrium Method, and I click on the Arc Failure Surface tab, a certain option comes up. You just draw your grid range, or sort of the range of your arc failure surfaces, and your arc tangent, over your slope, and then you following those two simple steps, you'd be able to create your slip surface. Oh, and also I changed the background color from white to black so that you can get maybe a better view of the grid range, because the lines currently are in white. So that way with black, you're able to see it a lot better.
Okay, I can see a grid though.
Okay, perfect. Okay, so did you see how I created the grid range and then the sort of the arc tangents along the slope?
No, no, the grid just was showed up, you know. I
Okay.
see, you know, it just showed up together with the black.
Okay, and then the background is it in black now?
Yeah, yeah. Are these the slip surfaces in your slope on the right side?
Yeah, on the right side.
So you're assuming like a block failure, a Newmark type of,
Oh no, it's going to be
uh,
a circular failure.
okay.
So yeah, if you want to assume a block failure, you could select a polygonal failure surface and you can create sort of that block shape. But with arc failure surface, what you do is you create a grid range and an arc tangent, and it'll create a series of sort of circular slip surfaces, and then the program
Right.
will choose the critical one for your minimum factor of safety.
Okay.
Um, and
So
also,
what are these,
yes.
what are these straight lines there though then in the right side?
Oh, those are your arc tangents. So, there'll be a certain number of tangents or circular tangents along those lines. That'll tell you, that's how you can tell the program, how many sort of curves you wanna model for your slip surfaces. So for currently there's 3 white lines, which is sort of the preset value. But if I wanted to create even more
Mm-hmm.
slip surfaces for more detailed analysis, I would create maybe 5 or 6 lines. And then, the program would create, more slip surfaces to analyze.
Okay.
Okay, so let me just, the next thing, because this is a seepage analysis, or excuse me, uh, a seepage slope coupled analysis, what I'll need to do is I'll need to import my pore water pressure loads from my seepage analysis. So to do that, it's very simple. Just go to Loads Boundaries, the top tab next to Model, and then just select Result from Other Case. So this isn't showing up in your
Okay.
computer, but it'll show up within, the next couple of seconds. You just filter through your computer to find the right projects. So I'll just select the one I just completed, and I'll select Import Results, and then it'll show up in my work window under Result. So yeah, just give it a second, and then it should show up. Oh, I see in your computer one of the tabs is open. So yeah, is the okay, not quite yet. So yeah, that's just another one of the great advantages of the program is like any data that you have from maybe a previous project that you completed in SoilWorks, you can just immediately import it into a newer, an existing project.
All right.
Okay. And what I'll do, just once again in the interest of time, I'll just finish up the analysis, and then it'll show up in your screen. Maybe I think there's like a 10 or 15-second differential. So you'll be able to see just how the analysis is sort of completed. Okay, so what's happening on your screen right now?
Um, Nothing much has not changed, you know.
Okay, yeah. So within a couple of seconds, a certain pop-up menus will come up, and you'll see how sort of step by step how I'm able to sort of import the loads from my previous analysis, and then create the analysis case, and then run the analysis. Okay, so do you see
Wow,
the
okay.
results? Okay, perfect.
Yeah, I'm looking at.
Okay, so the program just automatically tells you what the minimum factor of safety is. But I opened up the drop-down menu on the left, and then you'll see all the factors of safety that are available to you. And then also you can see that blue line there, sort of going along the top of the embankment. Yeah, that represents the phreatic surface or the water level. So that way
the water level, right.
Yeah, so the water level that was calculated from your previous your seepage analysis, it's imported into your slope stability analysis, and now it's taking pore water pressure loads into the slope stability analysis.
So that's the phreatic surface. That's the water level, though. The water level is actually reduced then from the 18.42.
I'm sorry, what was that?
I said the water level is actually reduced. It's somewhat influenced by the seepage taking place.
That's correct, yeah. So as you can see, it sort of forms like a curve. So like it's certain permeability, the permeability sort of changes over certain points. But just based on how the water flows through the material, I mean the water level will be different along different points. But as you can see, like most of the right side is sort of like fully saturated, and because there's pore water pressure there, there's going to be effective stress. So what the program does is it calculates those stresses and sort of how they act on your individual slices. So let me pull up the menu here, and if you double click on any of the slices in your arc failure surface, what you can do is you can see your free body diagram. So you can sort of see the the forces that are acting on each slice, and you can go from left to right to double check with everything. So that's just a brief demo, and I don't think it's showing up in your computer yet, but I'll wait until it shows up, and then we'll just sort of wrap up, and then hopefully the next time we meet, we can have one like a faster connection, so we can go over more material. We'll see if we can sort of work that out on our end.
Okay.
And then I know Beta said he wanted to go over a sort of a response spectrum analysis, so I'll go over that next time, and I'll go over the more of the constitutive models that are available to you. But you expressed interest in the hyperbolic constitutive model, and that's available to you in the software. So I'll show you how to use that model. Okay. So yeah, the free body diagram shows up, and once again, you can do that for each of your slices. You can go from left to right, and you can see the forces acting on all of them. So that's just a great sort of feature of the program. It gives you very detailed results. There's plenty of information that you can sift through. So all the results that you need, they're available to you.
Okay, it also gives you the interslice forces too then.
That's correct. Yeah, so those, the arrows to the left and to the right, those are your interslice forces. So I believe I used the Bishop's method for this one.
Yeah, the Bishop's. It is the Bishop's method.
Yeah, but also Spencer and then Morgenstern Price are available to you as well. As well as Jan. Oh yeah, so
I met with Morgenstern earlier this year.
Okay. Yeah, so in order to switch to Morgenstern, you just go back to your analysis case and you'd switch it from Bishop to Morgenstern. And then, I guess depending on your slope, you might get results that are sort of different. I mean, really with Morgenstern, the main difference is sort of the interslice forces. It sort of does a better job of that. It's sort of in that respect. But yeah, Morgenstern or Spencer, all sort of the main methods that are used for LEM, they're available in the program. Okay, so that about wraps it up for this part. I would go a little further, but because of the connection that we have, it could take a long time to go over everything, and I think we've taken enough of your time so far. But I mean, is there any sort of other questions that you have for me about the program?
There's just one more question I have for you, and it's along the line of not along the line of the hyperbolic model, but let us say you're doing the construction of an open dam. You'll be constructing it in layers.
Okay, you want to do a construction?
Different levels.
Okay.
Right, that's what I'm saying. I'm saying, so here you presented a full embankment here, a total levee, which is completed, and you're just running probably a seepage analysis on the levee itself. But during construction, there is a great possibility that the embankment can fail, considering your construction list. If you see your subsurface soil is probably not very weak, but if it is weak and then you creating an embankment, there can be a failure probably in what you call that, say, consolidated and drain failure or something of that type of sort. So
okay.
That sort of type. So I was just wondering whether or not the program can actually emulate the whole construction lifts in a sense, like and do such an analysis whilst in real time, basically.
Oh, absolutely. In the ground module, which is the module that's typically used for that type of application, there's a construction stage analysis feature where you can model sort of, so like you said, like typically embankments are built, with layers, or built, sort of sequentially, with sort of layers being sort of stacked on top of each other.
Right,
so,
right.
Yeah, what I can do is I can show you a construction stage analysis that'll take that sequence into account. And then what the program actually does is it takes sort of the deformations, the shear strains, etc., for each of those stages, so you can see sort of how your construction site changes, with time. And then also if you have temporary support structures, so for example, if you have like a retaining wall that's supporting an excavation or something like that, or maybe tiebacks, you can model those temporary support structures through various stages as well. So that'll take a little bit longer to, I mean, with the connection that we have right now, it would take a little too long to do. But what I'll do is I'll have something set up for you. Maybe, we can meet up later again this week and I can give you a more detailed presentation on that topic. But to answer your question, yeah, the program can definitely handle that. It's been used for several of those applications. And I guess, are there any particular, projects that you have in mind that you'd maybe want to try the program out on?
No. Anyone? What was the question?
Yeah, so like what I wanted to offer was like what we do with sort of engineers that are looking into, picking up the program. Sometimes they'll have maybe a future or a past project that they worked on, and they just want to see how SoilWorks handles it. So they want to compare to see, if it's easier to do on SoilWorks and also if they got the same results. So for example, do you have maybe any type of geotechnical project that you would want to test with SoilWorks?
No, well, not at this current point in time. If I would have to go in and try and get some, well, not at this point in time. I have a project, a dam construction, but
okay.
The information is like scattered over too many places.
Okay, a dam construction.
I would really have to try and get all the information.
Okay. So how far along has that project gone? I mean, are you currently working on it, or is it in the future?
No, that's a previous project. Though.
Oh, a previous project. Okay. All right then. So, yeah, I mean, we'll give you some time to gather the info, but in the meantime, I'll make sure to set up the construction stage analysis sample project for you, and then hopefully next time we'll have a better connection so that we can, sort of go through it a little faster. There's a lot more that I wanted to go over with you today, but unfortunately, just due to technical issues, we can't really go over it yet.
That's understandable.
Okay, no problem. And yeah, any other questions that you had that you have for me?
No, none whatsoever. Again.
Okay. So, what are your thoughts on the program so far?
Yeah, I'm impressed. I'm very impressed. Though. Give me 1 minute. Hold on.
Oh yeah, no problem.
Hello. Just hold on, Ethan. Let me call it out. Yes, sir. Yeah, like I said, I'm pretty impressed. It looks quite. It's not simple, but it's something that can be built very easily.
Yeah, definitely.
As long as you know what you're doing and what you're looking. But let me ask another question in terms of the assistance and your help, your manuals basically. Do they have manuals that guide you into the actual execution of probably different, not projects, but let's say if you're doing a CPG analysis or something of that sort?
Oh yeah.
Have manuals.
Yeah, we have several manuals or tutorials, sample projects that you can use to learn the program. So, we have a website where all of those sort of manuals are available and you can get them for free. And then another great thing about just our company is that we offer sort of around-the-clock technical support service. So you can give us a call or an email at anytime sort of during office hours. And then, we'll usually get back to you within the hour. And then, especially for new users, you understand that there's sort of like a learning curve involved. So with new users, myself or one of my colleagues would be assigned to, your account, and you could always just sort of call us up for project support. You can send your projects over to us. We can help you model them. We can set up customized training sessions, or we'd have like a webinar such as this, and we can maybe walk you through your project. So that's another, sort of big part of what we do. We don't just sell software, we also sell our services. So, when you're starting to learn how to use the program, you can always sort of rely on us for guidance,